Hi everyone. Section 0.4 is on absolute value and distance. Absolute value is a topic you think you know, but you don't, and you really do need to know it for calculus early on. Now let's start with an example to make you feel comfortable. What is the absolute value of 7? Well, it's 7. What's the absolute value of 0? It's 0. And what's the absolute value of -3? It's +3. So a naive student might say, oh, to take absolute value, I basically copy the number. Unless there's a negative sign in front, then I zap it. I remove it. That's the naive way of looking at it, though. And I'll explain why in just a moment. First of all, what is absolute value? Well, we can interpret it in terms of distance. So for example, why is the absolute value of -3 +3? Let's go down here. Interpreting absolute value as a distance. The absolute value of a, where a represents a real number, is the distance between a and 0 on the real number line. By definition, distances cannot be negative. Absolute value cannot be negative. Whoops, let's get a red color here. Absolute value cannot be negative. Distances cannot be negative. So if you look at the real number line, here's 0. Both 3 and -3 are 3 units away from 0. So for that reason, the absolute value of +3 is still +3. The absolute value of any positive number is itself. And the absolute value of -3 is also +3, because -3 is also 3 units away from 0, like the origin. So 3 and -3, notice these numbers are opposites. They have the same absolute value. In general, opposites have the same absolute value. So these are both true. So now let's go back and let's talk about the definition of absolute value using symbols. And it turns out to be a piecewise definition. You need to know this for calculus. The piecewise definition of absolute value. It's called piecewise because there are different rules for different values of a, the value you're taking the absolute value of. The absolute value of a, denoted by this over here, the a surrounded by the 2 vertical bars. The absolute value of a is a itself if a is positive or 0. In other words, if a is non-negative. That's a great word to remember. Positive or 0 means non-negative. If a is non-negative, its absolute value is itself. The absolute value of a non-negative value is itself. So for example, the absolute value of 7 is 7. The absolute value of pi is pi. The absolute value of your SSN, your social security number, is your SSN. What is it, by the way? Daddy needs to buy stuff on Amazon. And the absolute value of 0 is 0. All right. Now this is going to look weird to you. The absolute value of a is its opposite. It's the opposite of a if a is negative. Now you might be looking at this and you might be going, wait a minute. So when I take absolute value, I'm inserting a negative or opposite sign if a is negative? And the answer is yes. Because let's think about this more carefully. Let's look at the absolute value of -3. All right. Well, in fact, let's look at the rules overall. All right. So over here, so the absolute value of 7 is 7. Why is that? Because 7, if a equals 7, 7 is non-negative. So we use the top rule. The absolute value of a is a itself. So the absolute value of 7 is 7. The absolute value of 0. Well, if a equals 0, 0 is non-negative. So the absolute value of a is, again, a itself, because a is non-negative. We use the top rule. But now, what about the absolute value of -3? Let's type this out. Now, the absolute value of -3 If a equals -3, we take the bottom rule. If a is -3, we take the bottom rule. And the absolute value of a is its opposite. So the absolute value of -3 is the opposite of -3, which is +3. This makes sense because the absolute value of a negative number is positive. And we know that absolute value is either positive or 0. It's not negative. So again, the absolute value of a non-negative number is itself. The absolute value of a negative number is its opposite, which is positive. For example, in this case over here. Any questions about that? All right. So the absolute value of a, the opposite of a does not necessarily represent a negative value. If a is negative, then this thing here is positive. Not funny. Some properties of absolute value. The key thing is number 1. Absolute value is never negative. Again, it corresponds to a distance from 0. Some other interesting facts. Opposites have the same absolute value. Remember, in our example here, 3 and -3 have the same absolute value. 3, because these numbers are both 3 units away from 0. Opposites have the same absolute value. Also, and this comes down to the fact that absolute value is non-negative, the absolute value of a product is the product of absolute values, and the absolute value of a quotient is the quotient of absolute values, as long as you're not dividing by 0. So absolute value does break up across products or quotients, but not across sums or differences in general. All right. We talked about interpreting absolute value as a distance. The absolute value of a is the distance between a and 0. Okay. Oops. Make this bigger. The absolute value of a, which can be thought of as the absolute value of a minus 0, is the distance between a and 0 on the real number line. More generally, the distance between a and b can be written as either the absolute value of b minus a or the absolute value of a minus b. Either will represent the distance between a and b on the real number line. So, for example, if you consider x and 3, all right, I don't care if x is to the right or the left of 3. I don't care if x is greater than 3, equal than 3, or less than 3. Right? The distance between 3 and x, or x and 3, can be denoted by the absolute value of x minus 3 or 3 minus x. This is really convenient in calculus, because in calculus, we're interested in when two numbers are close to each other. And it doesn't matter which one is bigger, which one is smaller. So if you just want to know the distance between x and 3, and you don't care which one is bigger or which one is smaller, they could be equal even, then you can use either absolute value notation. For example, 7 and 3. If x is 7, all right, then your result's going to be is going to be 4, whether you plug in the 7 here or the 7 here. The end result is going to be 4, because the absolute value of 4 is 4. The absolute value of -4 is also 4. And why is that? Well, remember, opposites have the same absolute value. Opposites have the same absolute value. And I claim that b minus a is the opposite of a minus b. B minus a is the opposite of a minus b. I call that the opposite differences rule, or the switch rule. B minus a and a minus b are opposites. If you don't believe me, look at this. What is the opposite of a minus b? Well, we can distribute the -1. We get the opposite of a plus b. You can reorder the terms, and you get b minus a. The opposite of a minus b is b minus a. B minus a and a minus b are opposites. So for example, 7 minus 3 is positive 4, but what's 3 minus 7? It's -4, the opposite. 7 minus 3 and 3 minus 7 yield opposite values. In general, b minus a and a minus b yield opposite values, and therefore they have the same absolute values. The absolute value of b minus a is equal to the absolute value of a minus b. So it didn't matter which order you wrote the 3 and the x in, around the minus sign, if you have absolute value on the outside. All right. So again, this comes up in calculus because you want to know if two numbers are close, and it doesn't matter which one is bigger, which one is smaller. In these pictures, here x is greater than 3, here x is less than 3. But either way, either of these two expressions will work, the absolute value of x minus 3 or the absolute value of 3 minus x. It doesn't matter who's bigger and who's smaller. It's very convenient. Again, these both represent the distance between a and b on the real number line. Both are non-negative. All right, next up, you should know these rules of exponents and radicals. They're very closely related. Next time.